Right, we're going to start the next radio before we finish the other one. Still just need to finish off the transmit and do an on-the-air test for the Giessen 4004. I think the set's done. The problem is that the customer's microphone, the inserts failed, and we've got some spare inserts, but they're in one of the sheds, and it's been chucking with rain today. And so between the church services, I really haven't decided to walk across and get them. So, what we are going to do is going to move on to the next set. It was drawn to my attention by my CB friend from 10 miles away that there's one of these on eBay, and he didn't know what it was, because on the front panel it doesn't say what it is. So it's a CB2781 set. It's got that Harry Moss look to it. But anyway, it's a Kernow DW900 FM. There's a mark. When he came over, he checked it, and he says no TX, no RX. Query Mike, does that say? Probably standard Cybernet, I don't know. So this has got the lid off, and I'm going to do this as a part 1 and a part 2, because I'm not going to have time to finish this today, I'm sure. You know, it's getting on to the evening, and I don't really want to be working on a Sunday when I've already done a number of church services. That's got to go. You know, if you ever see this, where you've got a bit of stray wire like that, that does affect things. So that's that dealt with. So I don't recognise it. I probably don't see enough sets of this kind of era. We're heading towards that time when we were going to the other later specification of PR2794, because we've got the crystal filter, and the trouble is they end up going lopsided and the receive's inferior. So of course I might be wrong on this one, but you know, it's what happens. So put that on one side. I'm going to have to take the bottom lid off, and you will see in a moment why I say that. These suffer from going rusty. The damp gets underneath the whatever the coating is, vinyl type of coating, and they always seem to be like this. The self-tappers, which is annoying. I think there was a time when sets had to be really cheap to sell. It's certainly had some work there, hasn't it? So that's round. To SC 1173. Anyway, the reason I say I'm going to take the bottom off, I think you can see that is bulging. So I think it's been overvolted. So we're not going to power it up. Obviously Mark has. So we're not going to power it up till we've changed this capacitor. Lots of rework on this, and no doubt it's yet another of these intended for a different region originally. so. Yeah, 1000 microfarad, 16 volts. So for it to have gone like that, it's had more than 16 volts applied to the radio. Let's see what the test thing says. Probably says it's working perfectly. No, it's open circuit. That probably wouldn't affect the set from working, but there'd be a nasty hum. Right, I'll pause the video and go and get one. So on these sets, this is 25 volt rated, so it's a bit more hefty, and it's Nikon 1 and it's 105 degrees, so it's as good as it gets. Positive's the dot on these radios. We'll do the isopropyl alcohol later. Just solder that wire back. Just like that. I think I can see a dry joint, so we'll do that before we start. So although we don't normally start by repairing the radio, you know, we do like to see how they worked. You know, Mark's already said it doesn't work, so right, we'll get it connected to power. We'll get it connected to the test set. Let's hope it is the test set and not the aerial. So I spotted there's two on eBay. There's one for 30 quid as is, and then there's one for 59.99 allegedly working. Well, I'll tell you what, we'll put this one on eBay if we get it to work, and this one really will be working if I say it's working. Wrong lead. So, I think it will power up. There we go. The cracked bit of case there, which is sad. Well, it isn't powering up, so what have I done wrong? Oh, I'll tell you what I've done wrong. I've not plugged in the crocodile clips to the power supply, because we were doing a different type of lead. So it's powered up, it's on 31 because Mark was testing it. He can just sit there at a table and listen to himself over our tannoy system. So has it got PA? Yes, it has. So we'll plug the PA speaker in. We'll plug the test equipment speaker in. And I can hear a little hiss from the test instrument speaker. There's the public address one. We want our standard. I've got a brand new mic which I made up for somebody else, which will save me if I know where I've hidden it. Not sure where I've hidden it, but here's the another standard replacement mount which I made up for another job. So switch to PA. Testing 1 2, testing 1 2 3. Annoyingly, it comes through both the extension speaker and the PA speaker. So where's the pen gone? Well, that's ticked one box, hasn't it? You can hear it receiving. So let's put picture in picture on, and let's put it on the main meter. That's not the main meter, that's the main meter. It's one of those, is it, that's going to do feedback. Just doing 3 watts. Let's put it in the other power setting. It's doing 410 milliwatts. We're doing alright here. So it looks like I've fixed some fixings. Did I say 3 watts? I did. 3 watts, 410 milliwatts. Transmit currents 862 milliamps. Let's change channel. Channel 40 is 3 watts. Channel 1 is 3 watts. It's pretty well balanced. The RF meter, let's go back to channel 20, it's saying 4. Deviation, for what it's worth on this test set, wallow, it says 2.1, which is, if that's correct, is exactly where it should be. Let's just listen to it on our talkie-walkie. I probably told you before where this talkie-walkie thing comes from. When I was at Nottingham Radio, customer telephone, do you do them talkie-walkies? And from then on, that's what they've been. Testing 1 2, testing 1 2 3. Sounds a bit nasty, but it could be off frequency. So let's have a look if that is the case. It's virtually spot on, that. Slightly high, which is even, we're not going to be doing the VCO. Right, it doesn't have a meter lamp because it's electronic. So let's put that into the signal generator and see what it receives like. 27, 7, 9, 1, 2, 5 we want. 7, 9. That'll do. I've unplugged the extension speaker, haven't I? So let's have a look at the cyanide meter and get some figures. I've never seen one of these work before, so I'm kind of intrigued. So it's doing 0.38 microvolts. Wouldn't say it sounds nice. For 10 dB. I couldn't find any circuits, any instruction book, nothing about these online, and I haven't ever seen one before, so I've got no information myself. So if anybody's got a scan of the instruction book, which they can email me, that would be appreciated because it helps other people. So those figures look nice, but it doesn't sound nice. Let's put the squelch to full and just let's see. Let's go to the attenuator. Let's just see amongst the bits of plastic you can see. I want 100 microvolts, we're at 3, 10, 30, 100. It doesn't open at 100, which is where I want it. 300, 1 millivolt. It does open at 500 microvolts. So it does at least open. See where the threshold is. Put the signal generator to standby. Park it at point 3. Signal generator on. Squelch set. Here we go. Oh, that's deaf. So it's 2.8. So that would not be good round Scratchy Corner. It may not be better. We may not be able to do better than that. 100 microvolts on the signal generator is S9, and it is. Bring it up a bit. That's about where it should be. That's correct at the moment, but when we retune it will change. The sockets are working. We do know that. Switches. What else has it got? Both the switches are working, and both the potentiometers are working nicely. So nothing nasty there. So now we have to see whether we can work our way around it. So that's going to be the VCO. We're not going to be touching that. That looks like another part of the VCO, and it's the wax thingy. That's the detector on receive, because it's next to the chip there, which is going to be the FM chip. So I'm expecting that to be transmit. Not sure about that. It could be. These are going to be the IF. That's going to be the 10.695. That's going to be 455. They're going to be the front end, and then we're going to have some presets. Just change glasses. That's going to be deviation. I'd expect that to be transmit meter. There's our frequency adjust. Just put that upright. We've got another preset there. So it's not far from the FM chip. That could be the S meter. It could be the squelch. And another one there, which could be the S meter, could be the squelch. It's also possible that could be low power, but it may not be able to be adjusted. So that's what I see. So I'll tell you what, I won't fiddle with that yet. Let's go see if we can go through the transmitter. So put the main meter back on the screen. And I'm going to start there, and just put that back on there. Oh, and unplug the extension speaker. Hate it when sets do that. So that's reducing the power. We're at full scale deflection. Just see whether this one does as well. Yes, that's transmit, that's transmit. So that's going to be transmit. That feels broken. It is broken, but it's not broken so much as to not move. It might be possible for me to do that and the broken bit actually come out. So we'll go to the next scale now, and we'll go through this. I've bashed it so much it's no longer on. So I've that's definitely peak. That's now definitely peak. We're still at 3 watts. That's definitely peak, still 3 watts. Run out of adjustments, folks. So I think that's going to be the meter. I'll tell you if it isn't. It's not acting like it is. Let's drop it to low power. It's definitely the meter, because on low power. Hang on a minute. Oh yeah, that's low power, all right. So it's supposed to show 1 when it's there. Let's go into high power. Yeah, we're calibrated. So that's definitely meter. But our low power is 450 milliwatts now. Still 3 watts. When it cools down, it'll probably be 3.2. Just see whether some of these airspace coils are not in the right place. Uh, 3.1. About 3.5. Right. Where's our low power now? It's now 510 milliwatts. So it's probably not adjustable. I doubt it. Anyway, but by that time it wasn't a requirement. So deviation. Tell you what, I'll plug it into the test set behind me. We'll do that right now. Get it over and done with. Well, it's about 1.9, so it just needs to pop up a little bit. I'm sure it's going to be that one. Wallow, wallow, wallow. Yeah. Right, plug back into this test set. Catapult a few things off the bench. Good. Let's see what it says on this test set. Wallow. It says about where it is, to be honest. I think this is reading right today. I've got 1.9 on the other and I've got 2.1 before, so I'll tell you what, we'll put it was 2. And it's now 2.2 to 2.5 kilohertz, so that's done. So we may as well pop it on frequency while we're here. I mean, really, it doesn't need changing. It's a nice quality capacitor on this one. That'll do nicely because it dropped with age. 2779127, so instead of 125127. So that's that. So we'll start on the receive. Better plug the extension speaker back in. And 100 microvolts is on the signal generator. Let's put up the oscilloscope and let's have a fiddle with the detector, because it doesn't sound nice. That is spot on, so it's not that. Over to the synod meter. Lots of these sets with crystal filters, the filters go lopsided. And we've either got to go to the expense of changing all the filters. And to be honest, it doesn't really matter that it's slightly gone lopsided. It's not going to make much difference until they get quite bad. So I think we'll just look at the IF first. Better drop the squelch too. Drop it to about there. Yeah, so those have made quite a difference. So I'm assuming this is to do with the IF as well. Right, let's do the front end. That's correct, and I think that's going to be front end. Yeah, it is. Okay, so let's get a new reading. No, it's not. I've got that on the wrong scale, folks. That 3.8, 0.38 0.31 is actually 1, and 0.38 was 1.2, and 20 I said was 0.6, was actually 1.9 because I was looking at the wrong scale, so they were wrong. So now we're right, I'm on the right scale. See, I shouldn't be doing things at 8 o'clock at night. 0.7 0.6 20 is 1.15. I'm just wondering if this is one of these lopsided sets again. All these 30-year-old crystal filter sets seem to be lopsided these days. So I'll tell you what we're going to do. Here's today's experiment. Put that to 12 dB, and I'm going to untune the signal generator, see if it gets better. Worse. Better. Yeah. So instead of being a 79125, it's receiving it 79026. That's because the crystal filter has gone lopsided. So there you go. They're all doing it. The last set was doing it. That emergency Midland was doing it. So we're done. We're tuned as we're going to be tuned. What to do? Let's do the signal meter. So 100 microvolts on the signal generator, and we'll adjust what we think is either going to be that one or that one. So it's Hobson's choice here. So I want it to read S9. Should be meter, and it is. So I want it to be not quite plus 30, And now when we move the signal generator's attenuator, we get plus 30, and we can drop that down like that. So that's as good as we're going to get. Slightly lopsided, as I say. Let's do the squelch. So squelch to full. It's going to be different to anyway. So I've got squelch to full. We've got 100 microvolts on the signal generator. That's going to be the squelch preset. That's going to be the squelch preset. Okay, put the signal generator peg. Yep. So minimum sensitivity. Let's see what we've got on the signal generator now. It's not far off where I want it. It's 140 microvolts. So hopefully it's better than 500 microvolts. Now at the other end, I'm hoping the squelch sensitivities improve dramatically. So let's have a look. So signal generator, parking it at 0.3 microvolts to standby. Set the squelch on the radio to threshold. Signal generator on. It's not good, it's 1.7. Put 1.75 microvolts to be generous. It's come down, but we've got minimum sensitivity. Probably doesn't help with the IF being slightly lopsided with that filter. Nobody's going to pay for that to be replaced on a set which is a bit of an also-ran. So now it's cooled down a bit. That's still correct because we've redone it. Now it's cooled down a bit. We will see what power it's doing and on what channels. So we're on channel 20. It's not stone cold. So let's go over to the main meter. And 5 watts is there, so 4 watts is there. Well, here we go again. I do get sick of sets that do that. It's 3.4. It's 3.3. Well, it's better than a lot of new sets. It's 3.4. I'm just going to pop the power supply up to 14.4 volts, in line with the way a lot of cars charge these days, including our Nissan Leaf. 14.4 volts. Power supply back on, channel 20. It's 3.6 volts now. Sorry, it's 3.6 watts. So just turn that back down to 13.8. So it's only a stone's throw from being 4 watts, and they're quite entitled to say something's 4 watts when it's 3.5, aren't they? Because of the way rounding up works. So there you go. We are done. I'm not going to put it together at this stage because I want to do the printed circuit board. So whatever was wrong with this when Mark checked it, I've fixed. So whether it was some of those dry joints, whether smoke was coming out because of that capacitor, but obviously I've fixed it now. So that was quite an easy fix. So I'm going to. I'll tell you what. We'll put the, instead of putting the loudspeaker back in, I'll put the one on the wall in, which is we use as a PA speaker. Okay, I'm going to turn the signal generator off, turn all this gear off, and we'll put that off, and we'll put the roof aerial in instead. We'll see if we can hear any bad buddies in Nottingham with their burners. Well, Nana, Roger. You know, folks, there's just times where you couldn't make things up. It's now the next day, and I'm now recording an alternative ending to this radio. So I don't know whether I've got to the bit where I said, well, I'm not going to put it together because I'm going to get Mr. Chippie to clean the back of the board. And then I plugged it into the aerial. We didn't hear anybody talking, which is fair enough. It was like 8:30 in the evening. They might all be watching telly or whatever they do. So put it back on, because what I'd actually got yesterday, that knob's in the wrong place, isn't it? What I'd got yesterday was a fluorescent light on, which causes interference. So let's go around the channels. Somebody with a sensible conversation. It's 7:30 in the morning, 7:30, 7:45. One niner Roger. That's low power, isn't it? 19er Roger. Don't think the burner brigade are out of bed yet. So there we go. Yeah, this fluorescent light, where I clean the records, which is where you hear the ultrasonic cleaner racket, making a racket from. It's what it is, 5-foot fluorescent light, and it's a 1970s one, which would be a traditional ballast arrangement. And the ballast failed, and I put, because it was a faff to change it, a real faff. I replaced the innards with a really expensive electronic ballast, which was Swiss made, which I got from RS Components, and it causes so much interference, it's unbelievable. And I'd got that light on because I was cleaning records last night at the same time as finishing the video. So there you go, an alternative end. So we were doing on the air test. We'll get that G-SON finished and back to the customer. Thank you for watching the DW900 from Kernow. You don't see many of those.